Now here next point is about sum of n terms of some special series, not about arithmetic or geometric progression in general. So we discuss here first with this, let me call that as result number 1. But very important result you will use frequently later on also, even in 12th standard. That is 1 plus 2 plus 3 up to n. This is a series which is nothing but the sum of the first n natural numbers. How many? N natural number. Sum of first, summation of first n natural numbers. N natural numbers. Natural numbers. First n natural numbers. Now this being arithmetic progression 1 2 3, you can see that it's an AP. Here this is an AP with a equals to 1. First term is 1 and common difference, that is also 1. You want the sum of how many terms? N terms. So you can write Sn equals to here n by 2, first term plus the last term. First term is 1 and the last term is n here. So this is the formula. Which formula we've used? Sn equals to n by 2, first term plus last term. Right? We know it. I've used that. So what I have shown here is finally, let me write here, that is 1 plus 2 plus 3 up to n, which is, being addition, you can express in form of sigma, which I'll write here, that is given by n by 2 n plus 1. This is the very important formula here. This can be expressed in terms of sigma. Sigma, it means summation. Sigma, let me write here variable as what we write. You can use anything. Suppose I'm using here, let's write k. K runs from 1 to n, and I'll write k here, which is given by n by 2 n plus 1. Right? Now what is meaning of this sigma? If I take k equals to 1, you will get this. Sigma stands for plus. Before you choose the next value, you put the plus. So when I take 2, before that plus, so 2. If I put 3 here, then next before 3 sign plus, and so on. Last one plus, put this above number. This is read as sigma k, where k runs from 1 to n, it is given by this. This is just this much, remember. This addition you have expressed in form of what? Sigma notation here. Sigma. Sigma stands for addition. We know it very well. You already used earlier in statistics. Okay. Now various notations are used. You can use k, you can use r, and so on. I can write like this also. Or you can use the variable r also. Sigma small r, where r runs from 1 to n, n into n plus 1 by 2. It depends upon the last number. Right? What is the meaning of this r? R is just a variable. Put r equals to 1, you will get this. Plus, put r equals to 2, you will get this. Put r equals to 3, you will get this. And finally, this above number n, so you will get this. This stands for addition. For example, I want to get this 1 plus 2 plus 3 plus 4. Directly you can answer it. 4 plus 3, 7 plus 3, 10. But as per this formula, last number plus 1. So 5, 4 plus 1 upon 2. You can see that it is 10. Right? That's what you had noted. If I write this, one more example. Suppose I want to add 1 plus 2 plus 3 up to, let's write 100. So how I'll do this? Now it's difficult to do it manually, but you can use this formula. 100 plus 1, that is 101 by 2. So what you will get from this? This is just 50. So 50 into 101, right? That is here you can write as 5050. So that is your required summation of first n natural numbers. Clear? So one is this. result 1 you can write this or this. Now second result here, let me write result number 2. This was 1. Okay, that is 1 square plus 2 square plus 3 square up to n square. How do you describe this? Sum of the squares of first n numbers. Right here, first word is important. Sum of the squares of the first n numbers. Okay. How do I express this one in form of sigma? Sigma. I can use k. Anything you can use. Variable k. But here everywhere you have squared. So k square. K runs from 1 to n. If I put k equals to 1, 1 squared. Sigma means plus. Put k equals to 2, 2 squared. Sigma means plus. Put k equals to 3, 3 squared. And which is the last number? That is n. So here n squared. So the same thing you can express in form of sigma. And this is not AP, not GP. But using PMI you can do it. Even some other ways also available. But the formula is this. N by 6, n plus 1 into 2n plus 1. You can do it by PMI or you can refer the textbook. There are some other ways also. So I'll write that is this sigma k square is given by n by 6 n plus 1 into 2n plus 1. This is the formula. For what? Sum of the squares of the first n natural numbers. I repeat, sum of the squares of the first n natural numbers. For example, if I take this here, I want to get this. Let's try it here. Let me write, for example, first one, I want to get this 1 square plus 2 square plus 3 square. Now directly you can do it easily. What is direct summation? This is 9 plus 4 plus 1, so it is 14. Now I'm using the formula. Here n is 3, not 9. So I'll write 3 by 6 into 3 plus 1 4 into 3 into 2 6 plus 1 7. So what will get from this? This is just 2. So from this you will get 14. That's what you had expected, right? Directly. If I want to get this, suppose 1 square plus 2 square up to 10 square. Now directly to do it manually becomes little bit tedious. So what you can use? You can use the formula. Which formula? N by 6. You have n plus 1 into 2n plus 1. We might have done using PMI. Just check the PMI exercise. Okay, so here n is 10, not the 100, remember. So 10 by 6 into 10 plus 1, which is 11, into here you put 10. So 10 into 20 plus 1, so 21. Now the question is just simplification. So you have 2 here. Sorry, I'll write 3 here, I'll write 5, and this is 7. So what we'll get here? 385. Okay, so that way you can get this. Now we go to one more result. Let me write result number 3. That is also an important result. Result number 3, which is about 1 cube plus 2 cube plus 3 cube and so on up to n cube. What is this? This is sum of the cubes of the first n numbers. I repeat, sum of the cubes of the first n numbers. You can express in form of sigma notation also. Sigma k square where k cube where k runs from 1 to n. It starts from 1, it ends here. Okay, now what is the formula for this? This is neither AP nor GP. So you cannot do it directly using AP GP formula, but there are some techniques also available in the textbook. You can refer it, or by PMI even it can be proved. Here right hand side is n into n plus 1 by 2. This is the first formula, and then you just square it. So I can write as n squared into n plus 1 the whole square by 4. Right? You just need to remember the first formula square. N into n plus 1 by 2 the whole square. What was the first formula? N into n plus 1 by 2. Square it. That is the sum of the cubes of the first n natural numbers. For example, here I want to get 1 cube plus 2 cube plus 3 cube. Now what is this? You can get it directly very easily. This is 27 plus 8 plus 1. 27 plus 8 plus 1. So it's 36. Now get into RHS. Here n is 3, not 27. So 3 into 3 plus 1, 4 by 2 the whole square. So it is 12 by 2, which is 6. So you'll get the 36. Right? That way you can use these three formulas. So very, very important, these three formulas here. Sum of the cubes of the first n numbers, n square into n plus 1 whole square by 4. First formula square. What's the sum of the squares of the first numbers, n numbers? N by 6, n plus 1 into 2, n plus 1. And this is very simple, n into n plus 1 by 2. Fine. So these are the three standard summation formula which we'll use frequently. You will see when it is also useful in 12th standard. Now, before I get into exercise, let's see about this sigma notation. So you know it is expressed to write addition. Right. If you have addition, you can use the sigma notation to write in the compact form. Okay, like if I have, for example, this one 1 plus 3 plus 5 up to these are the odd numbers, n terms. So how do I express in form of sigma? You see, these are the odd numbers. Now how do you express odd numbers? You know, in 2k minus 1 form. And I'll put the sigma here and I'll write k runs from 1 to n because I want for n terms. So this way sigma can be used. See now, how do I verify whether what I did is right or not wrong? What you need to do is put k equals to 1, start with the lowest value. So 2 minus 1, 1. Sigma means plus. Put next value of k, 2. So 2 into 2, 4, minus 1, 3. Fine. Next, before you write the next term, plus. Sigma means plus. Put next 3. So 2 into 3, 6, minus 1, 5. Next, plus, and so on till the nth term. What is the nth term? That is 2n minus 1. So this way sigma notation can be used. You will see further once we start the next exercise. Before that, these are the two properties of the sigma. Sigma k runs from 1 to n. Suppose I have ak plus bk. That means what I'm trying to tell you. If you have addition, you can take the sigma inside. K runs from 1 to n ak plus sigma k runs from 1 to n bk. If you have addition here, you can take the sigma inside. Not only for addition. If you have minus, again you can take the sigma inside. And the next property, suppose I have k runs from 1 to n. Suppose I have c into ak. So this is a constant. Sigma depends upon k here. C is independent of k. So I can take c outside and I can write just k runs from 1 to n ak. Where c is some constant. Independent of k. Constant in that sense. If you have some constant, you can take it outside. If you have plus or minus, you can take sigma inside. If you have constant, you can take it outside. Right? But if you have multiplication or division, you cannot take the sigma inside. So this is not true. Sigma, if I have ak into bk, here k, then if I write like this, sigma ak into sigma bk, these two never be equal. And same thing for division. So if you into, you cannot take the sigma inside. If you have plus or minus, you can take the sigma inside. Okay? And one more, fourth one. Suppose I have like this here, sigma. Suppose here you have 1 and I'll write k runs from 1 to n. Now what's the meaning of this? Sigma has how many terms? N terms, but every time you have 1 only. So if I put k equals to 1 here, but there is no k, so 1. Sigma means plus. Put k equals to 2, but there is no k, so again 1. Sigma means plus. Next put k equals to 3, but k is not there, so again that constant 1. How many times you will be doing? N times. So even if I put k equals to n, but k is not there, so 1. How many times? N times. Can you tell me what is 1, 1, 1, 1 n times? Obviously it is n. If you write 1, 1, 1 3 times, this is 3. If you write 4 times, it is 4. So here it is n. Okay, like this. If I write sigma 1, I'll write r runs from 1 to 10. What is the meaning of this? 1 is added how many times? 10 times. 1 plus 1 plus 1, how many times? 10 times. So it will be just 10. This is 10. Fine? Okay, so this is all in all about sigma and those 3 first important results. Now, it is time to start the next exercise 9.4. So let's go for that. Exercise 9.4. First question here. Please read the question. What is asked in 1 to 7? Summation to n terms of the each series given below. Okay. So I'll call Sn because you are asked for sum of how many terms? N terms. You see here 1 into 2. This is like one term. Plus 2 into 3. This is like second term. Plus 3 into 4. This is like third term. And so on. Right? For how many terms? When you write Sn, that means for n terms. So your final answer will be in form of small n. Clear? Your final answer will be in form of what? Small n. Nice. Now what we do, in every question we cannot simplify directly. So we try to use the sigma notation here. We try to use which notation? Sigma notation. So you observe the terms here. See, look at each term. Do not simplify. Do not write 2, 6, 12 and so on. What we do? We observe first term. Let me write like this here. What is first term? 1. Second term? 2. Third term? 3. Okay. So I'll write here in general nth term. You can write here an equals to n into. So if I put n equals to 1, you will get 1. If I put 2, you will get 2. You put 3, you will get 3 into. Now what is the next number? That is first number plus 1. 3 is nothing but 2 plus 1. So what I should write? N plus 1. This is nth term. I wrote nth term from the series. If you recall the first exercise 9.1, you may get the idea. What I did, just I wrote the nth term. Put n equals to 1. So you see 1 into 2. Put n equals to 2. 2 into 3. Put n equals to 3. 3 into 4. Now you wrote the nth term. You want addition. So what is to be done? Sigma. For addition, sigma is the best option. Now same notation should not be used. So we use usually small k. So I'll write k into k plus 1. Have you understood what I did? And k runs from 1 to n. You could have done like this also, remember. Instead of this, you could have done like this. ak, which is k into k plus 1 if you are having confusion. You can do like this also. Right? But we use the k variable, small k. Or you can use the small r. Choice is yours, whatever you want to use. That's not important what you are using. This is just a variable. Now you can verify. Put k equals to 1. So 1 into 2. See, first term. Sigma means plus. Put next value. 2. 2 into 3. Second term. Sigma means plus. Put next 3. 3 into 4. So here and so on. So this is correct. Now, once I express in this form, this up to this step it is important. Now you can do it. This is not big task now for us. What we do, we just use the properties. I'll open this bracket and for addition you can take the sigma inside. The first term is k squared plus sigma, k runs from 1 to nk. Now what is this? You know this is nothing but the result number 1. Sum of the first n natural numbers. This is nothing but which result? Result number 1. Look at this. See? Sigma k runs from 1 to nk. 1 plus 2 plus 3 up to n. What is this? This is result number 2. Look at this. So we just place the values. Finished. And we'll simplify. So what is this? Remember, this depends upon the last number n. So what is formula here? N by 6, n plus 1 into 2n plus 1. What about this? n by 2 into n plus 1. Clear? Understood? Your final answer will be in form of small n. Why? Because you are asked for some of the n terms. Okay, now we can simplify here. Take n into n plus 1 common. By 6 also I'll take common. So here you are left with 2n plus 1. If I make it 6, you have 3 as the LCM here. N into n plus 1 already taken outside. So your final summation is n into n plus 1. What is this? 2n plus, plus 4 by 6. You can take 2 common here. Let me write here. Take 2 common and cancel with this. So n into n plus 1. I'm taking 2 common. So n plus 2. That 2 will get cancelled with this by 3. This is required summation of n terms of this. This is Sn. Sum of the n terms of the given series. Right? Final answer. You can continue with the next line. Now you can, if you want, you can verify. See, if I put 2 here, I must get the sum of how many terms? 2 terms. If I put 2 here, you will get this is Sn. If I put 2, you will get the S2. S2, you recall, what do you mean by S2? That is A1 plus A2, sum of the first 2 terms. Do you remember first exercise? Okay, so I'll put 2 here. So 2 into 3. 3 will get cancelled. So you are left with 2. 2 plus 2, 4. 4 into 2. Answer should be 8. Check here. 6 plus 2, 8. That means this is right. If I put 3 here, then I must get the sum of the 3 terms. Got it? Understood? Right? So what is important here, term here? Express in terms of what? Sigma. This is very important. This step, as I told you. Then it is not a big task for us, remember. Let's see next now. Second question. Which series you are given? 1 into 2 into 3, first term. 2, 3, 4, second term. Third term and so on. You want sum of how many terms? N terms. So what we'll do, we write first kth term or nth term, whatever you want to write, remember. Okay, so you will not simplify. As I told you, you keep in the same format. What is first term? 1, 2, 3. That means first term should be n. Next number, previous number plus 1. 2. Next number, previous number plus 1 again. So n plus 1 plus 1, that is n plus 2. Fine. This is which term? Kth term. Oh, sorry, I wrote n, so I should write an here. Fine. If you don't want to write an, you can write ak also. Choice is yours. I'm just showing you. K into k plus 1 into k plus 2. Right? Variable is not important. Got it? Now, before I go for sigma notation, we'll just simplify this. So k into k square plus 2k plus 2 and take k inside this. So what we'll get here? K cube. This will be, 3k here. So 3k square plus here finally 2k. This is ak, kth term. Got it? Put k equals to 1, you will get this. Put k equals to 2. This is nth term, remember. Put k equals to 2, so you'll get this. Put k equals to 3, so you'll get the third term, a3. We want their summation. That is the question here. So now you got the formula for nth term or kth term. Now we'll go for Sn. Sn means what you have to do? Just put the sigma in front of this. Sigma, k runs from 1 to n, ak here. But what is k? Kth term, that is k runs from 1 to n. Why I wrote from 1 to n? It always starts from 1, a1, a2 and so on. So we put always 1. Why I wrote n here? Because you are asked for sum of how many terms? N terms. Okay, so this is k cube plus 3k square plus 2k. Fine? Clear? Now we use the properties of sigma. Your job is almost done. Take the sigma inside. For addition, you can take the sigma inside. K cube. 3, you see, it's a constant. So I'll keep it outside. K runs from 1 to n, k squared. How do you realize that this is constant? Because there is no k with this. Plus 2 into here, what will get? 2 into sigma, k runs from 1 to n into k. Fine? I hope up to this you are fine. Taking 3 outside from the sigma, taking 2 outside from the sigma. You know one of the property. You can take the constant outside. Now what is this? You know this is the ready formula. This is also ready formula. This is also ready formula. So you need to remember those three results. What is sigma k cube? You know it is the first formula square. Where is that? Let me show you. It is the first formula square. This one. Okay, first formula square. What is k squared? You know it. K square is given by which formula? N by 6. Here, n by 6, n plus 1 into 2n plus 1. And what is this? You know it is nothing but n into n plus 1 by 2. So I'm putting this. This is now just algebra. First formula squared. Last number is n. So n into n plus 1 by 2 the whole square. So I'll write here 4. I'll write square here. 3 being constant as it is. You know this is nothing but here n by 6 n plus 1 into 2n plus 1. Plus here 2 being constant as it is. What is this? This is n by 2 into n plus 1. Clear? Understood? Now what you need to do? Simplification. Simple algebra. First you see what is common. Take that much common. So what is common? N plus 1 into n is common everywhere. Okay. This will be just 2. This will get cancelled. Fine. So you can take by 4 common here. Fine. So here you are left with what? N into n plus 1 plus I've taken by 4 common, so here you will be having what? 2. N into n plus 1 I've taken outside. 2 into n plus 1. Have you realized why into 2? Because 4 is LCM here. Plus, what about last term? N into n plus 1 outside. This 4 will go as LCM there. I hope this is clear to you. This is just simple algebra. N into n plus 1 by 4. What is this? N square. So I'll write n square plus n plus 4n. So how much? 5n. Okay, and this is 2 plus 4. How much? 6. You can keep this much. Otherwise, one more step if you want. You can see that this is very well known quadratic expression. It has 2 factor, n plus 2 and n plus 3 by 4. That's a required sum of how many terms? N terms. Clear? It is very, flow of the solution is very standard. Write the kth term, put the sigma, take the sigma inside and use the formula. This is the flow of the solution. If you want to just verify, put here 2 everywhere. So you must get the sum of the first 2 terms. This one plus this one. You know S2 is A1 plus A2. We know very well from the beginning of this chapter. So if I put 2 everywhere, just put 2. So we'll get the S2. It has to be the sum of this plus this. Okay. Next question, third one. This is the first term, A1, A2, A3 and so on. We write first nth term or kth term, whatever you write. So what we do, will not simplify. You observe first term here, 3, 5, 7. Can you observe? This is arithmetic progression. 3, 5, 7. What's the common difference? 2. Is it? So here it must be 2k. Always. You can verify. Now I need here in the first term 3. So I'll put the plus 1. Okay, I'm writing for n. So I'll write n here. No problem. So 2n plus 1. Now put n equals to 1. You see, you're getting 3. Put n equals to 2. 5. Put n equals to 3. 6 plus 1, 7. Got it? What I did indirectly, I have used an formula of an AP, a plus n minus 1 into d, for only 3, 5, 7 and so on. So what is a here? 3. N minus 1 into d. What's the common difference? 2. So what I getting? 2n plus 1. Fine. This is 2n plus 1. Now This is obvious. What is this? 1 square, 2 square, 3 square. So this will be what I should write? N square. I hope this is clear to you. 1 square, 2 square, 3 square. So in the nth term it has to be n square. Or if again I'm saying if you don't want to write this, you can write ak, which is 2k plus 1 into k square. Got it? Whichever you write, both are correct. Don't worry about it. Fine. Now you got the kth term or nth term. Now therefore Sn means what? In front of this you just put the sigma. Sigma always starts from 1 because we have always a1, you know, in sequence and series a2. So it starts from 1 and it ends at n. Why it ends at n? Because you are asked for sum of n terms for 1 to 7. If I change this question, if I ask for sum of 20 terms, then you are going to put 20 here. That will be S20. If I ask for sum of 10 terms, then you are going to put 10 here, but it starts from 1. AK, what is AK? That is this. 2k plus 1 into k square. Now for product, you cannot use the sigma. So what I need to do? I need to open the bracket here. So 2 into k cube plus k square. Then what is the next step? You know very well. Once I open the bracket, I need to take the sigma inside. So let's take the sigma inside. 2 being constant, it will come out. Sigma k runs from 1 to n k cube plus sigma k runs from 1 to n k square. Clear? 2 times sigma k cube, sigma k square. Okay. Now you can do it. Just place the value for this, you know, place the value for this and simplify. I leave it for you, not a big task. Now you can do it. I'm sure I did it twice. I'll go to fourth question now. Question number 4. Okay, there what is Sn? Sn is given by 1 upon 1 into 2 plus 1 upon 2 into 3 and so on. Right? So we need to write the kth term. So it's not difficult to observe here. Kth term ak will be, you see you have 1, 2, same format. So this is k. What is the next term? This plus 1. This plus 1. So this is k plus 1. Fine. So this is the kth term. Or as I told you a number of times, you can write the nth term. What is the nth term? 1 upon n into n plus 1. Now what is our next step? Put sigma in front of this. But now the problem is, if you have product, you cannot apply the sigma. So what we do, we'll simplify a little bit like this. 1 plus k minus k. What I did, this is a constructive step little bit. You will realize here. Why I did like this? Because now you do individual division. This will get cancelled. This is k. Minus 1 upon this will get cancelled. K plus 1. See, now instead of product you got the subtraction, and for subtraction addition you can take the sigma inside. Are you getting me? What I did, this is actually 12th standard technique. Instead of the product I could express in form of subtraction. You can put the minus sign between these two. Very easily you can notice. You see 1 upon 1 by 2, you can write 1 by 1 minus 1 by 2. You'll get the same answer. 1 upon 2 into 3, you can write here 1 by 2 minus 1 by 3. You can check, you'll get the same answer. Product becomes subtraction. Product becomes subtraction. Later on in 12th standard you will learn this can be done very easily, but here I have shown this. Okay, so this is a kth term. You want Sn. So what is our next step? We put the sigma in front of this. So let's put the sigma here. So our required Sn equals to sigma k runs from 1 to n ak. What is ak? That is 1 upon k minus 1 upon k plus 1, right? Before you use the property of the sigma, after the sigma your expression should have plus or minus. Into a division will not do. You know it. Now here I'll drop the sigma notation. Put k equals to 1 here. So we'll see that this is 1 minus 1 by 2. Sigma means plus. Put k equals to 2. So 1 by 2 minus 1 by 3. plus put k equals to next 3. So 3 and 4. 1 by 3 minus 1 by 4. And so on. What is the last value of k? That is n. So 1 upon n minus 1 upon n plus 1. Right? This is very interesting series. You will see here. This will get cancelled with this will get cancelled with this, similarly this one. And this will get cancelled with the previous one. You see, this will get cancelled with the previous. So here you are left with first and here last. So finally we are getting this 1 upon 1 minus 1 upon n plus 1. And this is just, if I take LCM, n upon n plus 1. This is required sum of the n terms of the given series. This is a special series, that's why this is happening, right? But your required summation is this. Put here 2, so we'll get the sum of the first two terms as I explained. This is called telescopic series. You can do googling, you will see. So here again sum of the n terms of this series. So we write nth term or kth term. So what we'll do? We'll not write 25, 36 and so on. We just observe this base. You have square, that is there. Now observe this base. What is this? 5, 6, 7 and so on. I suppose it's an AP. 5, 6, 7. So what's a common difference? 1. What is the first term? 5. Is it? A is 5. I'm not considering square. Without square I'm considering. So what is nth term? A plus n minus 1 into d. D is 1 here. So what we'll get here? N plus how much? 4. So we'll get here n plus 4 the whole square. Put n equals to 1. 1 plus 4, 5 square. Put 2 here. 2 plus 4, 6 square. Put 3 here. 3 plus 4, 7 square and so on. So this is an. An is this. Done? An or ak. Again I'm telling you. A kth term, that is k plus 4 the whole square. This is not important whether you use k or n. So now therefore required Sn equals to, now what is our next step? Put sigma in front of this. So k runs from where to where? 1 to n. Why 1 to n? Because you are asked for sum of how many terms? N terms. So I'm just putting here 1 to n. K plus 4 the whole square. Clear? Now for square you cannot take the sigma inside. So what we do here? We open this. What is this? K square plus 8k plus 16. Now you got the plus. So you can take the sigma inside. So sigma k runs from 1 to n k square. Formula for this. Take 8 outside. This is sigma k runs from 1 to n k. Why we have chosen it outside? Because it is a constant. 16 is also constant. I'll keep it outside here. So sigma k runs from 1 to n, here 1. Now everything is known to you. You know everything. Is this clear to you? 16 is constant. It doesn't depend on k. See, k square depends upon k. So I kept k inside. 8 doesn't depend upon k. So I've taken 8 outside, k as it is. Here there is no k. So 16 outside, here 1. Now write the formula, n by 6, 8 as it is, write the formula, 16 as it is. What is this? We have written before few minutes, 1, 1, 1, 1, how many times? N times. So it is n. Formula for this is known to you, formula for this known to you. Place the value and then just simple algebra. So you can simplify. Question number 6, try it for you. You can do it. Write nth term and then apply the sigma. Observe the terms 3, 6, 9 and so on. Okay, I'll go to 7th, which is really good question. Their series is given by 1 square. In the second term you have 1 square plus 2 square. In third term you have 1 square plus 2 square plus 3 square. In fourth term you have up to 4th square and so on. So can you predict what should be the nth term or kth term, whatever you write it? I repeat, see, it sounds very common. In the first term 1 square alone. In second term 1 square plus 2 square. In third term 1 square plus 2 square plus 3 square. So in the nth term it has to be 1 square plus 2 square plus 3 square up to n square. Or here you can write 1 square plus 2 square plus 3 square. In kth term it is up to k square. Shall I repeat? See, in the first term up to 1 squared. In the second term up to 2 squared. This is the first term, 1 square alone. This is second term, so up to 2 squared. This is the third term, up to 3 squared. So in nth term it has to be up to n square. In kth term it has to be up to k square. What should be my next step here? 1 square plus 2 square plus 3 square plus 4 square. Why? Because this is the fourth term. This is the fourth term. Got it? Is this clear? So now simplification. Do you know this is a known formula? I mean both. So what is this? This is, you know, k by 6 into k plus 1 into 2k plus 1. What is this? You know, I'm showing both. You can write any one of these two, remember. What is this? N by 6 into n plus 1 into 2n plus 1. Our result number 2. Sum of the squares of the first how many numbers? N number. Here k number. K into k plus 1 into 2k plus 1 by 6. So now I got the nth term, or you can call the kth term. So therefore required summation equals to Sn equals to sigma and kth term, where k runs from where to where? 1 to n. What is kth term? You did it now. Kth term is given by what? K into k plus 1 into 2k plus 1 by 6. 6 is constant. I'll keep it outside. Okay, and this product will not do. Now you know this. I repeat flow of the solution. What I did, I got the nth term first or kth term, and then just in front of nth or kth term I place the sigma. Why? Because I need the summation. Because nth term or kth term represent any particular term. We want the summation, so we put the sigma in front of this. Now this k as it is. What is this? This is 2k squared. K plus 2k, which is 3k plus 1. And now you take just k inside here. So this is 2k cube plus 3k square plus k. Fine. Why I did like this? Now you know very well, because for product sigma cannot be used. That you know very well. For product sigma cannot be used. So what I did, I have opened the bracket and so on. Now 1 upon 6 again outside as it is. 2 being constant as it is. This is sigma k cube. 3 being constant as it is. This is sigma k square. 3 constant outside. And plus the last term. What's the last term? That is sigma k here. Okay, now all are standard formula. This and this. We place the value and we'll simplify. So let's see that now. Okay, so 1 by 6 as it is, 2 as it is here, sigma k cube formula. So you know it is n square by 4, n plus 1 the whole square, plus 3 as it is. This is n by 6, n plus 1 into 2n plus 1. And the last one that we know, it is n by 2 into n plus 1. I have just written all the 3 formulas to remind you. Right? First formula, that is n by 2 into n plus 1 here. Second formula, k square here. And third formula, cube here. So we have just 2. This is also 2. 2 you will find outside. So 1 by 12. N into n plus 1 you can find common. So n into n plus 1 you can find common here. What is this? Again n into n plus 1 plus here just 2n plus 1 and here just 1. This is just simplification. Okay, by 12. What is this? N square, n plus 2n, 3n plus 1 plus 2, which is plus 2. Now this is very standard quadratic equation. You can factorize. What are the factors here? N plus 1 into n plus 2. You can just verify. Factors of this expression, whole by 12. So we have n into n plus 1 the whole square into n plus 2 by 12. This is required summation. sum of the how many terms? N terms of the given series. You can just verify by putting the values. Put n equals to 2, you will get the sum of the first two terms. Right? What is S2? Just look at its series. That is 1 square plus 1 square plus 2 square. I'm just verifying for your information. 4 plus 1 5 plus 1 6. Okay? Put here n equals to 2, you must get the 6 and it has to be 6. Just place the value, you will realize. If you put n equals to 2, you must get the 6 from these also. That means what you did is correct. I'm just giving you an idea, right? No need to verify for every question. Okay, from 8 to 10, these questions are again easy for us because this term is already given to you everywhere. Right? Here you got this term from this. Here this is given to you. So you need to continue like this. Okay? If you look at it, even previous question, fifth one, here you got this term from this. Now you are given, so just apply the sigma and continue. Okay? So I'll just go to 8th, one step. What is an there? N into n plus 1 into n plus 4. Right? This is given. You are not decided. In earlier 1 to 7 question, you were deciding. What is asked? Sum of the n terms. That is Sn. So what we do? Just you need to put the sigma in front of above notation and we write ak here. So sigma k runs from 1 to n. What is this? K into k plus 1 into k plus 4. Have you realized what I did? Just instead of n I wrote k. Now open this. Make it cube and take the sigma inside. You know you cannot take the sigma inside directly. You need to open this. This is k square. Take sigma inside. So k cube. 4k plus 2k. 6k. So 6k square. I repeat. 4k plus 2k. 6k. Take this inside. 6k squared. 8. Take this inside. 8k. Now take sigma inside. Use the formula for cube, square and k as I did here. So I'm sure now we can do it. Question number 9, ninth one. There, what is an ready given to you? N squared plus 2 raised to n. Okay. Now after learning so much about AP and GP, I'm sure you must have realized what is this. You are asked for sum of the n terms. The required summation equals to Sn, sum of n terms. What is that? Sigma k runs from 1 to n ak. So this is sigma k runs from 1 to n. Ak means here k square plus I'll take the sigma inside. K runs from 1 to n 2 raised to k. Have you noticed what is this? Once you have power, it seems to be what? It has to be what? Can you recall? Once it is the power, it has to be what? Yes, geometric progression. This is GP, remember. This is AP and you have prepared, sorry, this is not AP, but for this you have a prepared formula. What's the formula for this? N by 6, last term is n here. N by 6, n plus 1 into 2n plus 1. You know formula for this. Okay? N by 6, n plus 1 into 2n plus 1. What is this? If I just rewrite here, it's like this. 2 plus 2 square plus 2 cube and so on. Is it? Sigma means addition. Put k equals to 1, 2. Put k equals to 2. So 2 square. Sigma means plus. 3, k equals to 3, 2 cube. Everywhere addition. This is a GP. What is the first term? Here a is 2. What is the common ratio? You can write 4 upon 2, 2. 8 upon 4 again 2. Can you recall some of the n terms of a GP? A into what is that? You know, r raised to n minus 1 upon r minus 1. Do you remember this? So here, for this one, a means 2. R is also 2. So 2 raised to n. Why n? Because you want the sum of n terms upon r minus 1. So we have here n by 6, n plus 1 into 2n plus 1 plus here we know here this is just 1, so 2 into 2 raised to n minus 1. This is a required summation. And now last question, I'll just show you one step for you there. In the 10th question, what is an? That is 2n minus 1 the whole square. Ready? Nth term you are given. So what is Sn? You just put the sigma in front of this. Sigma k runs from 1 to n, 2n minus 1 the whole square. Now for whole square you cannot use the sigma. So what you need to, sorry, here I should write k because variable is k. K, usually we write the ak. This is just ak. Okay, open this. So 4k squared minus 4k plus 1, right? What is this? 4k squared minus 4k plus 1. 4k squared minus 4k plus 1. Now what is the next step? You know, take the sigma inside, 4 being constant outside, k square. You have ready formula for this. Minus 4 being constant outside, this is just k, sigma k, plus this is sigma 1. Clear? For each of this you have prepared formula. What's the formula for this? You know, here it is up to n by 6 into n plus 1 into 2n plus 1. 4 constant as it is. What's the formula for this? N by 2 into n plus 1. 1, 1, 1. How many times? N times. So this is just n. Write the formula for this. You know it. I'm not writing. 4 as it is. Write the formula for this and simplify. That is exercise here 9.4.